Thank you all for coming. I'm going to have a talk about text analytics in enterprise search. We have this short little agenda here. I'm going to introduce you all to the concept and how you can think about this in the context of enterprise search. So I'm going to bring up some benefits of implementing text analytics, and I'm going to show you all what kinds of possibilities there are once you have this implemented. And what I'm going to do is I'm going to show you a couple of examples of how this has been implemented by us at Findwise. And I'm going to show the solution behind how you actually can go about implementing this, these techniques. And then we wrap it up and take questions. Okay, so a little slide about me. My name is Ling. I work for Findwise, one of the sponsors here. So if you have more questions later, just come by our stand up there. I've been an enterprise search consultant for 5 years. Started out actually working with Ling back in 2006 when Apache Solr was still incubating. But it was kind of hard to scale your search back then with Ling. You could run into all kinds of problems when you wanted to implement enterprise search with Ling. So I went on and did consulting on fast ESP for a couple of years. And then we know that Microsoft bought it, they dropped the Linux support, etc. So I moved on, and right now I'm quite focused on Apache Solr. And that's what I do at Findwise mostly. So Apache Solr is my primary search platform, and I focus on concepts like findability, the search architecture or implementations, etc. And text analytics is one of my focus areas. So I've done about 20 enterprise search implementations in ranging industries, from intelligence agencies to media companies. So what we're going to see here is that I have some conclusions about that text analytics can actually bring some benefits to all kinds of enterprise search solutions. Okay, so we're gonna start up by defining text analytics and what the actual benefits are. So we're all on the same page here. And one thing you have to think about when you're gonna implement text analytics in an enterprise search is that there are specific challenges and benefits of implementing text analytics within the enterprise. So if we start off with this fact that about 80% of the data within an enterprise today is unstructured data. Okay, so that can be a big challenge, and we tackle this with enterprise search, but if we go about text analytics as well, we can bring some more structure to this data. And some other challenges that we want to tackle with text analytics is that we want to support the same kinds of things that enterprise search is trying to solve, like reducing the time that knowledge workers spend on looking for information and stuff like that. So these are the challenges we want to tackle with the text analytics together with enterprise search. And if we look at this from an enterprise perspective, we know that for enterprise search solutions, we have a quite predictable amount of information. We know that it's growing, but it's not like we're trying to apply this to big data, like going onto Twitter and doing text analytics there. But we have this predictable scale, and we have this domain knowledge when we're doing text analytics within an enterprise. So we can have someone who actually knows this domain within the enterprise to help us out doing text analytics. We have this well understood domain, right? And we can also have supporting content that can be used for text analytics within the enterprise. I'm going to show some examples of that. Okay, so if we take one step back and actually look at the definition of text analytics. What we're doing is we have this set of techniques and tools like linguistic, statistical, and machine learning techniques, and we want to apply them to our textual source. And what we want to do is we want to build some models and some structure from this information. Okay, so if we start by looking at the types of applications and features we can build with text analytics. We're probably familiar with most of these. We can do the entity extraction for taking a set of text, extracting different kinds of entities from that we can benefit on later. We can do document categorization to set a label on a document on what kind of category does this document belong to. There's other approaches to document categorization, including sentiment analysis, where we set for this set of text, what is the sentiment here? Is this a positive or negative document, etc. And we can do some summarization as well using text analytics techniques. So these are the kinds of applications I'm going to focus on showing here and show you how to solve in the context of enterprise search. Some frameworks and techniques that can be used. We all know that we can benefit from what Lucene and Solar can figure out from our text in the index. We can get some statistics. We have this term vector component, for instance, where we can get a lot of statistics about how frequent terms is in documents and in the index, etc. So we can actually benefit from this when we're doing text analytics. And we have this big set of open source tools out there that can also be used. You may have heard about Mallet, Classifier for J, TextCat. All of these focused Java libraries that we can use to actually implement some text analytics. And then again, we have these other big frameworks that can be used, like Mahout, Gate, etc. So there's a lot of different approaches to tackling text analytics, but we're going to stay quite focused here on using a few of these. OpenNLP is getting quite big as well. So before we get started on the examples, let's look at the benefits and possibilities here. So using text analytics to bring some kind of structure to unstructured information, that's the basic concept here, okay? And what we want to do is we want to enhance the discovery and findability of the content that we're putting into our enterprise search solution. And the benefits we can get from that is we can use it in our relevance. We can get a better precision when we're doing the search later. Once we have this, once we have identified the category of documents, etc., we can use that in our relevance, like we're going to see. And the extracted keywords, etc., it can all be used for different kinds of features in enterprise. We can use it for facets later. We can use it for the relevance. So there's a lot of benefits with using text analytics here. Another kind of application that we can use it for is for doing topic pages. Having the solution select the kinds of documents around a topic and generate pages around that. The best example that's out there on that would be New York Times topic pages. It's all search driven. Other kinds of benefits we got here, we can be able to discover sentiments within text to facet on these. It can be quite useful in some contexts. And actually having the end users reduce the time they spend looking for information and analyzing that with the benefit of text analytics, it's a great value from that. Okay, so the way we're going to do this is we're gonna have a look at three kinds of implementation of text analytics. We're going to have a look at the concept and what it can actually look like in the user interface, and then we're going to have a look at the solution on what kinds of techniques were used to implement this and how you can configure it and set it up in your Solar. So the first example will be for entity extraction. Okay, so we mentioned this. It's the possibility to extract these kinds of entities from a free text. Extracting dates, places, etc. In recent years, some companies have also started focusing on actually extracting events to be able to predict things and doing more advanced analysis. But something to remember here is that if we're doing entity extraction on concepts like companies or places, stuff like that, it can be a quite fixed set of entities that we want to extract. So one example of how this could look like in a user interface, we start out with a search result hit here where we have just the title and the extract of the text. But after we implemented some text analytics, we extracted some more entities, and we were able to display this in a quite new way, extracting the source, which was in there in an unstructured format. We had a date when this document was initially published, extracting these from the text, and getting a sentiment on the text. This would be a news article, and actually identifying the sentiment and visualizing that with a green graph there. And then again extracting some countries that were just mentioned within the text. A similar example, extracting countries, the sentiment from the text, and some examples of companies that were identified within the text. So you could actually visualize it like this for the search result, or you could use it for things like your facets. So once you have extracted these entities, you can build new facets using these entities and enhance the discovery in your search solution. Okay, so what would be one simple way to implement entity extraction for your enterprise search solution? That would be to set it up with a rule-based entity extraction. It's a quite simple approach, but it can work in a well-defined domain like we have in enterprise search. So the way we do it is we generate, first of all, lists of entities that are possible entities to occur in the content, and then we set up some regular expressions. So this would be a very simple approach to get started with extracting your entities within your text. So again, this can work in enterprise search because it is a well-understood domain. We can, for example, extract all the companies that are our customers. So we extract these from our, say, the CRM system. We put it into a list, and then we can use it from there. And we could also generate the countries from pre-existing lists like the World Factbook, etc. And another approach to generate these kinds of lists would be to make a small crawl and get the list, such as crawling the Google Finance page, getting all the public companies into a big list, and using that as a list for extracting all the companies you can find in your text. Okay, so once you have generated these kinds of lists, you could set it up with the update chain, something that Jan Höjdal talked about yesterday, which is the processor steps you can set up in your Solr config to process the documents coming in for indexing. So you have this list, and you set up a processor for checking the content coming in against this list and extracting the entities. So that would be a quite simple approach, with basically adding new fields to the documents with the entities found within the document. So new documents coming in, you process it through this update chain, extract the entities, put them into a field on the document, and then it goes into the Lucene index in Solr. So the approach is quite simple on how you set it up. You would have this processor where you define the lists it reads this list from the startup. You define the kind of fields you want to put the entities in, and then you got it there. Okay, so that would be quite a simple approach to entity extraction. One other technique in text analytics would be document categorization. It's basically to have your solution put a label on your document saying what kind of category does this document belong to. If you have really unstructured information and content, this can be useful to have this set up and get your content more structured. And you can also use a similar technique to getting the sentiment analysis right. So we can have a look at how you can do this. But the way it works is that you build a statistics model or knowledge, you could say, from existing documents to build different kinds of categories. So you train up your tool on this, and then you will be able to label new documents coming in. The way it could look like is once it's implemented, we can make sure that we can enable the facets on the categories. So having the solution, putting the right category on each of the documents, we can enable the facets on that. Same thing for the sentiment analysis there. So one interesting thing about this is that, for example, for news articles, if you have a really strong positive or really strong negative sentiment on a document, we could also use that in the relevance to boost on these, because those are usually more important documents. Okay, so the way you would usually set this up with document categorization would be a 4-step process, where you need to do some preparations first. You need to have a set of defined documents that you actually train your tool to build this model about what kinds of documents should be in what kind of category. So once you have that preparation done, you can start training your tool, sending in documents with a set category. So the tool can actually build this knowledge or statistical model this way. And then you will start testing, sending in new documents to see what label this tool sets on each of these documents. And once you verify that it does it correctly, you can put it into production. So these are essentially these 4 steps for doing the document categorization. One of the tools that we used recently was the Mallet tool, open source Java library for machine learning. But there's other approaches as well. You could even benefit from what Lucene Solr can do. For example, with a more like this component, you could, if you have indexed and trained, so within the Lucene index you have documents with a category already indexed. And when you send in a new document, you could make a query based on that document and see what other documents and categories it matches within your index and label that new document with that. So you can actually benefit from the Lucene index when you're doing this with a more like this component, search component. So there's a few alternative components that you can use here, but the focus here is on Mallet. So once you train the tool, we're going to have a look at how you train it, but once you trained it, the way it works is that you just send in new documents and Mallet looks up in its statistical model on what kind of category does this document naturally fit into, and you can get a value from how well it thinks it fits into each of the categories, so you can have a threshold on to make sure that it's actually the right category. And the way you would usually train a tool like this would be you could set up an interface for training it, or you could make it ad hoc or index pre-categorized documents. For example, you could feed in Wikipedia articles where the category is already set. So if you take Wikipedia content, the category is already there. You can start training the tool with that kind of data. And then it builds the statistical model. Okay, so some code on how this would be set up in Mallet. Mallet has its own pipeline for processing the content coming in. And you set up what kind of algorithm you would like it to use when it trains on new content. Once you have that set up, you need some input. That will be content that you already know what kind of category it belongs to. So for sentiment analysis, you would send in content that you know is positive or negative here, for instance. You send it into this tool, and it builds this statistical model of these kinds of categories. And next, you could have this tool evaluate new text or documents coming in on what kind of category it belongs to. So you could set this up again as a processor in your update chain. So it looks up in Mallet for a field, like the text field of a document. What kind of category does this document belong to? It looks in the text field of the document, looks it up in Mallet, and sets the category on the category field. So you have that on your document that you index with Solr. So it's not much code, but once you trained it, set up this update chain processor, it can work like this to set a category in a document. One third application of text analytics will be document summarization. It's not totally search related, but you could put it into your enterprise search solution and bring some benefit from that. The concept is basically that you can summarize the text of specific fields coming into your search solution. You could do it at index time, or you could do it on demand when you're looking at the document and have Solr summarize text on demand. We're going to look at that. And the way we do document summarization is building a statistical model of the text coming in. So identifying from a text coming in, what are the most important sentences within this text? Picking out the most important sentences from this algorithm, picking out those sentences and building a new summarization. And as the input value, we could define like how long summary do we want from this text field, so we can get that. Some kinds of applications that this could be useful is, again, topic pages. Having at index time, having the search solution doing summaries of specific fields. So this could be the fields that the summarized fields that we displayed in a search-generated topic page, for instance. Or in a search solution, we could have it to do summarization on demand. So we open a search result, looking at the document, and once we scroll down to have a shorter summary, we could have the text analytics component via Solr do a summary of this text. So for the user looking at a long text, using this slider here, the user would actually be able to summarize the text. So starting from a long text in the interface, when the document is open, using this slider to summarize it down, you drag the slider and you get a shorter summary. So that could be one type of application where this could be useful, and it supports this benefit that we want the user to be able to find the content, the relevant content, even after they open the search result. So it's all about taking the user from putting the query in, finding a relevant document, looking at the document and making sense of the document this way. Okay, so the component is not actually building new sentences here. It's actually picking out the most important sentences. So based on text analytics, we are determining what sentences are most important within the text and picking those out for the summaries. Okay. So the way we do document summarization is, first of all, we need to do this, for the example I showed, we need to do this with a new request handler. So we implement our own request handler and our own search component. So we send in to Solr the document ID of the document we're looking for, the document we're looking at, and the field that we want to summarize. So it has to be a stored field in Solr. And once you send that into the request handler, Solr picks the document and the field that we want to summarize, and our implemented search component would take that field and build a model to pick out the most important sentences for summarization. And then send that data back to the interface. So just an extract of the code within the search component actually doing the summarization. Again, what we send in is the document ID, the field we want to summarize, and how short we want the summary to be. We send this in and we ask the code to summarize by word count, selecting the most important sentences. And the mode, this all works by building a model from the text, splitting up the sentences, splitting up the words in the sentences, and then looking for each of these words in these sentences. How often do they occur in this text? And then we put a score on each of these sentences where it's common words within the text found in sentences, and the sentences that have the most common words within this text, we pick those sentences out. We set a higher score on those sentences based on this model. We select those sentences and we send it back to the interface to get this kind of summary. Just to wrap up here, the examples we looked at was simple entity extraction within enterprise search, doing document categorization within the update chain to setting a category on the document, and summarization powered by Solr. So the conclusion would be that you can use this kind of technology to get started quite quickly with text analytics and gaining some benefits on the solution. And this all features and leverages from what's already within Solr and Lucene, but you could add those external components as well. And the value, of course, will be that this actually increases the discovery and findability of the solution, building new kinds of facets, and having the user actually find the content they're looking for and discover new content. All right, so if you have any questions, or if you come to think about questions later, you can send them by email. So I'm working with Findwise. We have this blog where we blog about new innovation, and this topic is going to be a blog post there as well. Okay, so do we have any questions? Yeah. So the question was if we should take the query into consideration for building the summary as well when we're doing the summary. It's a good idea. Actually, it's not implemented the way we do it right now, but that could be a next step. I think it's a good idea. Yeah. Okay, so the question was about the entity extraction. When you're doing entity extraction, the kinds of problems you could run into, for the example he gave was extracting a company like Orange, which could be something else as well, and approaches to tackle that problem. Okay, so the thing with this simple approach that I showed was that you have these lists of companies that you know that can possibly exist. And so for the example you gave, Orange, this model would assume that would be one of the companies within the lists already, and the regular expression would make sure that it starts with a capital O for example, so to make sure that this. But this could be a typical problem if you take another approach to entity extraction where you want to train the tool to do entity extraction. This could be a problem for that approach, but in this approach that wouldn't really be a problem because the regular expression would make sure that it matches. Yeah. So the question was about the kinds of limitations you can run into with this approach with entity extraction. Well, there are a lot of limitations you can run into, but it all depends on what kind of domain or solution you're trying to implement this for. So for a very small or medium scale enterprise search solution, this could be an approach that works. But if you have a bigger set of kinds of entities that you want to extract, this would not be the way to go. You would have to use a tool that takes into machine learning on what kind of entities to extract. So if you want to extract other kinds of locations, like all kinds of cities and villages, etc., you would take the machine learning approach and not this one. So, for instance, OpenNLP would be one approach to build on the entity extraction for unknown entities that you not know previous to indexing. Okay, so the question is about how much training and how many documents do you need to put into training to get this document categorization right. So again, it depends, but the thing is that obviously the more you train the tool, the more accurate it's going to be. And if you can take public data into your training of the categorization, for example, the example with Wikipedia, where there is categories, you could train this. That would be a good data set to train the tool on. But for the example you gave, where you have 80 different categories, well, really hard to tell. You would have to try it out in your domain, actually. Okay, so the question was about if these kinds of techniques are language independent or not. Well, for the case of the summarization, for example, the kinds of language-specific techniques it uses, it includes the stemming, for instance. When it builds this score on each of these sentences, it uses stemming for each of the words when it builds this statistical model. So you would have to get the right stemming for the right language that you're doing the summarization on to be able to do it. In terms of rule-based entity extraction, I would say you could use this approach on several languages. It's quite language independent. And with document categorization, I've trained it on just a few languages where I get good results, but I think you could apply it to a lot of languages, but you would have to know the language of the documents coming in, so you send it to the right set of trained mallet data. So there were two questions. The first one, if these techniques have been tried on languages such as Asian languages, right. Yeah, for instance. And the other question was, what was the other question? Which tool I would recommend going further. Okay, so I haven't tried it on Asian languages, actually, so I don't have a good answer for that. But when it comes to these different kinds of tools, the book that inspired me a lot and that covers this really good is the Taming Text book. And there's some really good examples in there, for example, for the OpenNLP library. So a library like Gate can get really complex to implement, but a tool like OpenNLP has a quite good approach, and you can find a lot of tutorials and examples out there. So going for OpenNLP, I think it will be a good approach. Okay, so let's wrap it up. Thank you all.